This video is on the objective, make a conclusion and interpret the results of a one-mean hypothesis test where the population standard deviation is unknown using the critical value / rejection region approach, or just the critical value approach. Alright, so this is another objective where we're performing what's called a one-mean t-test, right? Because the student's t-distribution with so many degrees of freedom will be showing up here, and that's because you have a population standard deviation that's unknown, right? Sigma is unknown, so the student's t will show up and not the z, not the standard normal. So again, if you're unfamiliar with the topic, want to see how they're doing things, click on More Instruction, look at their videos, their notes, their examples, and hopefully those help you. Alright, so here it says, Olivia gathered data on the average percentage of tips received by waitstaff in 31 restaurants in Chicago, right? So she had a sample size of 31. She works through the testing procedure, right? So her null hypothesis, what you're assuming, she's assuming that the average percentage of tips received by waitstaff for all Chicago restaurants is 15%, or 15. And then she's testing this alternative hypothesis that, maybe she thinks that the average is actually, the average percentage of tips is less than 15 for all restaurants in Chicago. She's testing at a significance level of 10%, right, 0.1, alpha 0.1. Alright, so she takes this sample of 31 restaurants, finds their mean percentage, their average percentage for these of tips received by the waitstaff in these 31 restaurants. That would be the X bar. Then finds the t-score for that. The X bar minus 15 is this mu0 here. This what's the assumed average, divided by the sample standard deviation S divided by the square root of 31. Right? She'd do all that, and she did all that, and it came out. The t-score, the test statistic for her sample, is negative 1.16. Alright, then, using the significance level of 10%, we'd be looking at a student's t-distribution with 30 degrees of freedom. I remember the degrees of freedom for a one sample t-test here was the sample size minus 1. So if you look at a student's t with 30 degrees of freedom, and this is a left-tailed test, the critical value came out at negative 1.310. And I'll draw a picture of all this. I'll just pull up a piece of paper here right on the screen here. Hopefully that's big enough for you. Pull that up. Alright, so we're looking at, again, students t, right? Our sample means for samples of size 31 would be a student's t distribution with 30 degrees of freedom. And remember, a student's t-distribution, right, so is very similar to a z distribution, very similar to the standard normal. The number line is t-scores, which are just like z-scores, right? The number of standard deviations away from the mean. How many are you? Still a symmetrical bell-shaped curve, right? Just the size or shape of this curve, the width of it changes depending on the sample sizes. Right? It's not like the standard normal. That's always that way. Underneath the peak here is a t-score of 0. And the mean that would have a t-score of 0 would be 15, right? The mean that's assumed from the null hypothesis, right, that I got in the box here. So back on my piece of paper, this t-score of 0 would correspond to having a sample mean of 15. Now, the critical value they mentioned was negative 1.310. So if I go, here's negative 1.310. I'll put CV for critical value. That's the t-score, right? That's the t-score that has an area of 10% to the left of it, right? This is an area of 10% under the curve. And this is our rejection region. Right, this would be our rejection region. And then the test statistic, the t-score for her sample of 31 restaurants came back at negative 1.16, which is not in the rejection region. Right? This was the test statistic, or I'll put test stat. Came up here, which is definitely not, negative 1.310 or less. It's not in the rejection region. So I would not reject the null hypothesis that the mean is equal to 15, that the average percentage of tips received by waitstaff in all of Chicago is 15%. I would not reject that. So I'd keep that, and I'd not support the alternative, that the mean was less than 15, and this is probably, this is what's being tested here. I would not support the claim that the average was less than 15, because we're not rejecting the null hypothesis here. So down here it says, I fail to reject the null, and the reason for that is because the test statistic does not fall within the rejection region. All right, you got to answer both, and those go hand in hand, right? If you're saying that you fail to reject the null, that means the test statistic was not in the rejection region. And the other two go hand in hand. If you reject the null, that means the test statistic is within the rejection region. Okay, and I believe there's a second part to this question. So now that I've decided, whether or not to reject the null hypothesis, and again, please read your answer explanations. Then they're going to have interpret the results. Using the information above, choose the correct conclusion that interprets the results within the context of the hypothesis test. So we already said we should not reject the null. So it's either this second option or fourth option. Let's see, because T0 is less than T alpha. Nope. If this were the case, if my test statistic was less than the critical value, then I would have been in the rejection region. So it's got to be this fourth option, but let's read it all just to make sure. We should not reject the null because our test statistic was greater than the critical value, the T alpha. So at the 10% significance level, the data do not provide sufficient evidence to conclude that the average percent of tips received by waitstaff in Chicago is less than 15%. And that's what I was saying earlier. If you're not rejecting the null, right? If you're keeping this mu equals 15, that means you're not keeping or not supporting mu is less than 15. So you'd say that there's not enough evidence to show that the average is less than 15%, right? And that's what this is saying. There's not enough evidence. The data do not provide sufficient evidence to conclude that the average percentage of tips received by waitstaff in Chicago is less than 15%. So this all kind of ties into the stuff up top. And again, please read through your answer explanations, whether you're right or wrong, especially if you're wrong, right? Just to make sure you can figure out where you went wrong, and hopefully when you see a problem like that again, you'll do better. All right. So hopefully this video here, it's pretty quick and easy. It's just, you're given critical values, you're given the test statistic. You just have to determine whether or not that test statistic is in the rejection region determined by those critical values. Should be pretty quick and easy. And then, interpret the results after. That might be the harder part. But hopefully this video helps, when you're going through this kind of problem on your own, and thank you for watching.